Hey everyone, how's it going? Today we're going to be looking at significant figures. Now, this relates to all measurements that we take in chemistry and how uncertain they are. We look at how to correctly report and use results in an experiment. Alright, so significant figures are meaningful digits. They tell us how precise a given measurement is or how close they are to the actual value. So let's just take a look at this picture here. So you'll notice that we have a lot of precision right here, but they're not hitting the target. Then we have quite accurate, but they're not hitting the target exactly where we want them to. And then if we look at the last one here, we're very accurate and we're very precise. So that means an accurate measurement is a measurement that is close to the correct or accepted value. So if you think your height, if you measure it and you know you're 5'8", and we get that, well, we know that it's accurate. A precise measurement is a reproducible measurement. Therefore, we can measure our height again and again and we get the same answer. The more precise something is, the more significant digits or figures it has. So if we look at significant digits or significant figures, let's look at 85.34. It's a fairly precise measurement, all right? And so it's got 4 significant digits. And I write sig figs. Next, we look at 2.3. We've got 2 sig figs. Next, we've got 1.23004, and we've got 6 sig figs. So these are very accurate number. Now, if we measured it over and over again, we got the same answer, then it would be precise. So nice and easy, right? Well, we have a couple rules. And so right now we've got 0.0000123. Well, it turns out this one only has 3 sig figs. And you're asking why? Well, we never count leading zeros. We only count the actual numbers, the trailing numbers. Next, 2.10000. Well, it turns out that we've got 6 sig figs. And here's the next rule. We do count trailing zeros. Notice the difference? So we don't count leading zeros and we do count trailing zeros. Next, we've got 210,000, and there's no decimal, so we've got 2 significant figures. However, with no decimal, the trailing zeros don't count. So let's try these. Well, 1.23000. Well, we've got a decimal there, so we're going to count our trailing zeros, and we have 6 sig figs. Next, we've got 0.000345. Well, we don't count leading zeros, so we just have 3 sig figs. Next, we've got 1.3 times 10 to the 6, and we have a decimal there, and we do count our, so we've got 2 sig figs. And finally, 223,000 with no decimal, we do not count our trailing zeros, so we just have 3 sig figs. If you want to get some extra practice, you can try question 42 on page 28. Have a good rest of the day.